So there's a trend towards big, right? So nobody quite knows how big GPT-4 is that powers ChatGPT now, but certainly of the open models that are available, Falcon I think is 180 billion parameters. We have Bloom 176 billion that we've trained a chat model on as well. And so it tends to be large models. And so this actually, for it to be effective, you have to have a pretty large footprint of hardware to actually be able to train. And then there are implications in terms of inference. So you were touching on, hey, we have NVIDIA, we have these other things. How does sort of hardware fit into this AI ecosystem, right? And so if you look back 2 years ago, maybe even 18 months ago, like 90+% of the inference that was being done on CPUs, right? So people would go and train their models, they might train it on a GPU or something else. And when they essentially got that, then they would take that trained model and they would do inference on a CPU and they'd be done with that.
I think it would be interesting maybe to give yourself or give the audience a little bit about the background on what you're doing, but also more importantly your story in working in the Valley and how you sort of made the move. I think you have a very interesting background, to say the least. Do you want to just maybe give a quick backstory and intro on you? And then I think that will give us the stage to sort of leap from that and jump into a bunch of topics.
Yeah, so let me just do the quick, what am I doing now, right? So I've spent probably directly the last sort of five years or so working on sort of AI ML type things. So currently I run software engineering at a company called SambaNova Systems, and SambaNova builds its own chip for accelerating machine learning. So we do training and inference at large scale for large language models, which are obviously very popular since ChatGPT was released over a year ago. And my team is responsible for building the compiler, the system software stack, and all of that allows us to do, rack scale systems, multiple rack scale systems to train the largest models that are out there, and also do inference on the quick view into my journey to the Valley and things. So I came to the US in 2000, which was kind of an interesting time to come because it was just as the original dot-com bubble was inflating and then bursting. I got to experience a lot of that. So I graduated with an honors in computer science. I did a major in maths and computer science and a minor in physics at the ANU. And my graduation present from my parents was a round the world ticket. And so I went backpacking, climbing. I did some mountaineering in New Zealand, traveling through the US and Europe and things. So when I came through the Bay Area, I went just knocking on doors on companies, right? I had an offer of a job with Accenture back in Australia that I was intending to take up in, I think I said I was going to start working for them in August. And I thought, well, I'm here, but let's see what Silicon Valley has to offer. And I actually had the benefit of having dual citizenship, so I didn't need to worry about the visa situation at the time. And I just talk to companies. I called companies up and I said, look, can you put me through to somebody who can talk to me about what positions you have open? And they said, well, we don't normally do that. And I said, well, I'm not normally in the area. And I was just aggressively looking for opportunities. And the company I ended up working for kind of had a career fair the week that I was here. And I went in and talked to people and they offered me a job. So my first job was at a company called Linux Works, where we're developing sort of real-time embedded operating systems, and I was doing sort of kernel and networking development for them. And because, it was the dot-com bubble and they were just desperate for engineers, I said, look, I know it's April and I'm talking to you now, but I'm in the middle of doing this trip. So, do you mind if I finish my trip and come back and I start working for you later? And they said yes. So I continued my trip and came back and started working in the US of July of 2000. And, it's certainly been an interesting journey. We'll probably get into some of the details more, but the Nasdaq peaked in April of 2000, and then it was kind of this interesting downward cycle. And then September 11 happened in 2001, and kind of the bottom dropped out of the tech market at that time. And it's interesting to compare with where we are now, currently with the economic situation, with what it was then. And I would certainly say in that 2000 to 2002 period, it was certainly uh, you know the tech market had created way worse than it is now in terms of hiring and layoffs and all of those sorts of things. But yeah, so I won't bore you with all the details of the last sort of 23 years, but a lot of it has been doing system software development, deeply technical work, both OS development, systems development. I worked at a startup building, Blade supercomputers. I was at NVIDIA and helped sort of, establish and create CUDA as the API of choice for accelerated computing. That led to a lot of this AI development just now. I was at Sun where we were doing sort of distributed object storage, which is obviously quite popular these days as well. So there's a lot of different things. I feel very fortunate to have been here because they're just the sheer breadth and depth of technology that is available to sort of be involved with is amazing.
What was the experience of like knocking on doors, so to speak? Because I know that back then there wasn't a strong, obviously the way that we reach out to companies nowadays, the LinkedIn of the world's glass doors and all that stuff,
Yeah,
right? That didn't exist. It's interesting to see that the way that you reach out to people is different from what it was then and it is now.
yeah,
I think email was coming around. It was still, it
yeah.
was, up and coming, and it wasn't as ubiquitous and prolific as it is today. But what was the way that you sort of reached out to people? Because I think there'll be a lot of folks out there listening saying, well, that's really cool that you did that, but I just don't know where to start.
Yeah. Well, so it's interesting you asked that because I was keen to work here in the US anyway. I mean, in part because I was born here and came back to Australia and did all my schooling in Australia. So I was keen to experience living in the US. So I actually applied via email to companies when I was in my honors year, right? And like I was very keen on Silicon Graphics. I mean, most people probably don't know who they are these days, but that was sort of like one of the cool companies that you could work for back then. And I got nothing, right? There were several different companies I would like shoot an email, like, apply on their website. Websites existed back then too. Um, but mostly it was like yelling into the void, right? There was no response. And so what I found was actually coming here, identifying, what companies were doing things that I was interested in. So like there was a company called Interval, and so Interval was funded by Paul Allen, the co-founder of Microsoft. So people used to talk about his endeavors. They would call them spam, spend Paul Allen's money. But what was interesting about that particular company is I was still quite interested in the intersection of research and industry. So when I went through the US, I also looked at a couple of places for doing PhDs. Like I stopped in at MIT to get the information about doing a PhD. And but what I found sort of really compelling about working in Silicon Valley is you're doing this groundbreaking work, but you're doing it in a way for a company, getting a decent wage, and you're moving the boundaries of knowledge and capability forward. And so how did I do that? So I did some of the old-fashioned things. I actually found their phone numbers on the website, and I called them up and asked to talk to somebody. I think I went into their offices and I had a printed copy of my resume, which I then handed over the desk to sort of people. And I guess I just got to be really annoying, to say, hey, look, I'm here. I want to talk to somebody.
It mirrors very similar to what I did. Obviously, albeit it was much later on. It was probably 15 years later, but
Yeah.
I think the process was the same. and obviously the technologies I used were different. Obviously, email was there, the LinkedIn was there as well, but the process of just reaching out stayed the same. And throughout time, you just have to sort of knock on doors, so to speak. And I
Yeah.
remember like, in I was in Sydney, and then I felt that after graduation, I was like, oh, like I wanted to do maybe like a postdoc or a master's, and I wanted to also have the personal experience, much like you, to sort of like live overseas. And like, what better way to combine that than like, okay, live in the US and do the work that you want to do? But I eventually realized, and I had a few buddies of mine working in the US saying that if you're able to work in tech and more specifically work in the Bay Area or Silicon Valley, I think that
Mm.
becomes, an advanced degree in and of itself, because you definitely learn so much from amazing people around you. And I remember just like reaching out to people remotely from Australia. That was also tough as well, because why would they hire someone from halfway around the world when they can
Yeah.
just hire someone locally? So I made it an effort to sort of like, once I was on the ground, and just to send out as many emails as I could, or send people like messages saying, okay, I'm in the area. Do you guys want to meet? Or I'm happy to come down to
Yeah.
the office for like an interview and all that stuff. So I feel like it's definitely worth trying, because you just never know what's going to happen. And it was lucky for you as well that everything worked out in the end. And,
Yeah.
what was that process like as well? Like, once you got the offer, did you have to come back home? Obviously, you don't have like that E3 visa like what I did,
Yeah.
but you feel like you still had to pack your bags and sort of organize a start date
Yeah.
and all that stuff.
No, 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 for sure, right? So I had all of that stuff sorted out. So, actually, my start date was July 10, 2000, right? So I came back, and so with my ticket that I had, I could change the flights, but I couldn't overlap the flights. So I had to, like, a couple of flights I had to bring right next to each other so I could get home with enough time to like pack my bag. So I ended up getting back. So I grew up in Canberra, so I got back at the beginning of June, and I basically had about 4 weeks to pack my bags to sort of fly out. And I remember I had like two backpacks that I essentially packed. And I somebody said to me, so I play a lot of field hockey, or hockey, I guess. This audience knows what I mean when I say hockey. Um, but somebody said, oh, that there is some hockey that they play in the Bay Area, and so I talked to a friend of mine, and she said, oh, you should just take your stick. So I stuck my hockey stick in the side of the backpack and brought it over with me as well. But yeah, I arrived with two backpacks, and that was all I had. And now, sadly, I have a lot more stuff than I did back then.
Uh, I want to sort of talk about now, sort of like the work you've been involved in over these 23 odd years, because I think you mentioned a few companies there. You mentioned Sun Micro, which I think now is Oracle, more or
Yep.
less. And it's interesting to see someone like you, more or less a veteran in that space, who's seen and mostly done it all, especially in technology. I think that's the operative word, is that you haven't really digressed orthogonally into other areas. You've really maintained a steadfast trajectory into the depths of technology, which is really incredible to see. But I also feel like there's a lot of lessons to learn as well. With the initial work that you did at Linux Works, at Dell, at Sun Micro as well, what have you seen evolve over these 2 decades, right? I know
Yeah.
it's a conversation in and of itself, but I love to sort of get your take and on your impression about how you've seen technology evolve, the work that you've been doing at Sun Micro, and then how that has changed and sort of exploded out of the valley and now
Yeah.
touching so many lives around the world, right? You've been on the ground firsthand at the front line and seeing, exactly what's been happening. What have you seen over these 2 decades?
Yeah, so that's a really deep question, right? So I think there are a few things. So let me talk about some of the changes that have really, I think, changed the technical landscape. So, and there's a lot here too, but So back when I came here, right, in 2000, if you're going to do a startup, one of the first hires you might make is an IT person because you'd have to set up servers, you'd have to set up your own
Mm-hmm.
email systems, hey, maybe you need to have a website, you'd have to figure out how do you get connect to the backbone. So there's a lot of these things that people used to have to do to establish a company. And then probably what you were building at that point wasn't just a software thing, it was kind of a systems thing, right? And typically that's what you'd see in the Bay Area. And so if I look now with AWS, GCE, Azure, like it is totally possible as an individual to go and create a very valuable business with the infrastructure that's available today, with all of those hosting environments and things like this, and in a way that actually you don't even need to necessarily be here in the Bay Area to do that. I mean, obviously is value in terms of funding and talent and making connections and things like that. But there's a lot of infrastructure that is sort of around now that just wasn't even there like 20 odd years ago. And then also having a look at how the types of businesses have changed. I mean, so obviously, with the iPhone and smartphones, that has dramatically transformed, you know, what, some of the technology. But, like so when I sort of got here, and even probably for, up to about 2010 or so, um, there was still very much a hardware software systems business. Right. So when I joined Dell, when did I join Dell? I think 2011, 2012. So part of what Dell was trying to do at that time is they had acquired some storage companies like EqualLogic, and the gross margin for the products at that point was 60% or more, right? And Dell had mostly been selling laptops to consumers, some servers and things like this. And most of the hardware that Dell was selling had like a 20 to 25% gross margin. And I think Michael Dell, he sort of looked at this and goes, "Oh my God, we have to make all of our own storage systems because, you know, this is where the money's at, right?" And so he had previously, well, I mean, now they've acquired EMC, but they've been partnering with EMC and other vendors. But they said, okay, let's build our own stuff. And so I joined to help establish a team to sort of do some building ground up of storage systems for Dell. And I mean, obviously Dell still exists, but if you have a look at that whole market, it really it's the bottom has dropped out of it because of what the cloud hyperscalers can provide instead, right? So you have this probably the core business, 20 years ago were these system software stuff. As the smartphone came in, there was a little bit more of a transition to software-based things. And then suddenly with, AWS and all of these other things, there's been this dramatic transformation into to software being king, right? So what is it? Mark Andreessen's quote is software is eating the world. And, what you find with this is the margins are great. With AWS and other things, you don't have to set up this infrastructure. There's a lot of tooling and support services that are available there now. And how does this look? Now, there are some caveats to that, right? So obviously, I work at a systems company still, and we're selling systems to people on-prem systems. But I would say a large part of the technology market is very software focused now than what it
Mm-hmm.
has been.
Yeah, I think that's true. It's mostly true as well because I think there is, that infrastructure layer or the infrastructure foundation had already been built quite a long time ago. I think there's obviously now iterations on that. And then you
Yeah.
mentioned AWS, Google Cloud, Azure, and all that stuff. But I'm seeing now that there's also this transition where obviously software is becoming dominant in sort of what we're doing, and obviously overlapped with AI as well. And you have this sort of ecosystem. And yes, AI obviously it's mostly software, but there's a strong emphasis on hardware as well, making things
Yeah.
more optimized. And obviously that ties in with the work that you do against SambaNova, but also with NVIDIA doing now enhancements on their GPUs, TPUs from Google, and so on and so forth, right? There is definitely a push towards optimization and efficiency at the sort of the physical layer. So what is sort of the approach that maybe, and you mentioned obviously the work you do in SambaNova, you know, do you, before we sort of get into the nuances of the AI ecosystem, maybe just explain a little bit about what SambaNova is for the sort of
Yeah.
uninformed. You know, what are they building, but also how does it tie in with what everything is going on right now with AI? There's so many things, there's so many elements. There's obviously the big ones like ChatGPT and OpenAI, but I think what people don't realize is that there are so many other elements within that ecosystem that make up what AI is and going to be. So maybe just a high level on
Yeah.
SambaNova and then we can go from there.
Yeah. So let's touch on this quickly. So, as I mentioned, so SambaNova, we build our own hardware, but essentially we present ourselves as a full stack company. So we want to be the solution of choice for business AI, right? And so what does that mean? So, if you look at OpenAI and some of their models and, Anthropic and others, typically they have a public model that's available. I mean, some of this is changing a little bit, as the market's moving quite quickly. But for a lot of business customers, they want to be able to have private model. They can use their data, and they don't have to be concerned about their data sort of
Mm-hmm.
getting out there. And so SambaNova very much has the ability to do large scale training with a relatively small footprint. So about a month ago, we released our most recent chip, which, well, anyway, we can go to some of those details a little bit more. But the comment I was going to make was the previous generation of chip that we launched, I think it was August or September last year. At the time, we said, hey, you can train, I think at the time it was the GPT 13 billion parameter model. And you could do it with a 6 times smaller footprint than you can use with GPUs. And I think it might have even been 6 times faster. I forget the exact numbers. But the reason why I sort of bring this up is if you look at the AI market, so there's a trend towards big, right? So nobody quite knows how big GPT-4 is that powers ChatGPT now, but certainly of the open models that are available, Falcon, I think, is 180 billion parameters. We have Bloom 176 billion that we have that we've trained a chat model on as well. And so, it tends to be large models. And so this actually, for it to be effective, you have to have a pretty large footprint of hardware to actually be able to train. And then there are implications in terms of inference. So you were touching on, hey, we have NVIDIA, we have these other things. You know, how does sort of hardware fit into this AI ecosystem, right? And so if you look back 2 years ago, maybe even 18 months ago, um, like 90+% of inference that it was being done on CPUs, right? So people would go and train their models. They might train it on a GPU or something else. And when they essentially got that, then they would take that trained model and they would do inference on a CPU and they'd be done with that. Um, where that sort of falls apart a little bit is with these chatbots, right? So if you have this 100+ billion parameter model and you want to have this illusion of interactivity with this chatbot, then it's likely milliseconds or microseconds that you need to be able to do this inference. And so you need the power and the capability of these hardware chips for acceleration, but you also need a large amount of memory to be able to fit this model in so that you can do that quickly in a low latency way to sort of respond to things. So, in terms of so SambaNova fits in, we have kind of this full ecosystem of hardware and system software. We have open models that can sort of plug into to the top of that. But then there is this other ecosystem of various different players who are trying to compete in the model space, right? So OpenAI, Anthropic, and others that are all sort of trying to do that, and they are trying to sort of say, hey, our model is better than your model. Whereas what we're saying is our system environment is the best for doing sort of business AI. You can take this thing, you can plug in the model you want to use, and then it can be on-prem, and you can do it in a way that sort of protects your data.
So I took a few notes here down because I think there's some interesting points you made. So first and foremost, SambaNova is full stack, meaning it goes all the way from the hardware layer all the way to the software, and even so to ultimately the application layer. And so from
Yeah,
that, you have this ability, or at least within the AI ecosystem now, there's a lot of players. You mentioned Anthropic, you mentioned OpenAI, Google, and what have you. But those guys are more or less developing those large language models. They're training them, they're inferring from them, and then using billions and potentially trillions of data points in order to
yep,
optimize these models. But the thing is, though, it's you can't really do any of that, or well, you can, but it's going to take incredibly slow on general purpose CPUs. So the whole point of what we've been seeing over the past decade is that people like NVIDIA, people like Google are developing specific hardware in order to do this. And I think, we can call them just ASICs in general. And
yep,
these ASICs or application, I think, specific integrated circuits, they're just sort of like custom chips that are being developed in order to do specialized functions. And so SambaNova is sort of coming into that sort of ecosystem and really building out, using their own IP and proprietary technology to figure out ways to train things much more faster, probably optimize on memory and speed, and using different types of sort of design methodologies in order to sort of achieve that. So I know maybe we can go a bit more technical here because I'm actually really interested,
yeah.
without giving away too much on what some on the sort of the hardware level, what sort of optimizations are you guys doing in order to do this? Because I know that
Yeah.
NVIDIA already have, they've been doing this for years and they're starting to iterate and optimize. How is SambaNova different? Is it similar? What sort of are you bringing to the table in that respect?
Yeah, so let me geek out for a second and let me know if it's going a
We
little
can go deep,
too
man.
deep or not. So uh, so the hardware architecture we have is something called a data flow architecture, which has been around for a while. But what we built is essentially inspired by there's a paper out of Stanford called the plasticine paper. And so our hardware often gets referred to as a coarse-grained reconfigurable architecture, or CGRA. Now, what does that mean? It's a little bit like an FPGA. Again, if that, let me explain a bit. So, what happens is we can kind of take a look at the model that we are looking to accelerate on our hardware, and we have ways to kind of map the characteristics of that model into how we configure the memory and computational units on the hardware, how they should connect in a way that maps very closely to the graph and the model that we want to accelerate, right? So we can go, okay, this is how these things work. Okay, let's map that down onto the hardware and then essentially push the data through these computational units in order to sort of drive the acceleration. And so from a computational standpoint and a data flow standpoint, that's something that is more unique to us. There are a few other startups that have some similar things that they're doing with respect to that. Another area that I would say that we're unique, say, compared to NVIDIA, is the amount of memory that we have available, right? So typically, if you look at a high-end enterprise class GPU, they have about 80 gigabytes of high bandwidth memory. And with our most recent announcement for the SN40L, I think we have about 60 gigabytes of high bandwidth memory, but we also have about over 600 gigabytes of DDR, right? So slightly lower speed memory, but again, it's a pretty large amount of memory that we have associated with the computation. And why that's sort of valuable is for these large models and these large language models, they're more memory bound than they are compute bound, right? So by having that large amount of memory, it means that we are able to better utilize, essentially the flops that the chip has. Now, how does this sort of compare to GPUs? Um, so, GPUs, they have a bunch of different processing units on the GPU. You can kind of spread things out and calculate in parallel. Um, but it's not, sort of reconfigurable, right? You're kind of essentially trying to get everything down, as much as possible to being a calculation that is independent of each other. And if you happen to have something that's embarrassingly parallel, then that works pretty well on GPUs. If not, then you might hit issues. And then there are a couple of other sort of design constraints that NVIDIA has, say that SambaNova and some of the other hardware startups in this space don't, right? So at its core, NVIDIA is building a GPU for doing graphics, right? They still have um, well, at one point I think it was 50-50, sort of the gaming business with the data center business. I think the data center business is now more than that, but it's still, billions of dollars a year that they're making by selling, that hardware to people who want to do graphics related workloads. And so they can't, drift too dramatically from that in terms of what they're trying to build. Whereas, for SambaNova, our customers are doing AI, right? They're, large language models and all of these sorts of things. And so if there are optimizations that we can make from a hardware design standpoint, we have the ability to go and make those changes without being concerned that there's a legacy graphics business that we need to support.
So with and that totally makes sense. And I see a world where there's going to be, well, the thing is, I mean, in my mind, like when you're trying to access a space like the sort of the hardware space and building a specific custom chip for AI, I mean, there are already high barriers to entry, but nonetheless, I think that there's still an opportunity for disruption, and especially what SambaNova is doing. There's a lot of companies now trying to get into that space because they see that, all right, the LLM space is really pretty crowded. There's Hugging Face, there's
Yeah.
Anthropic, and all that stuff, right? And they're specialized, they're good at what they're doing. But then below that, there's the hardware level, and the very specific hardware, knowledge and know-how that allows you to have those LLMs trained. Do you see a world where we're going to see more people come in to the space that SambaNova is working in and try to disrupt? Because I wonder how many more players will there be that will give or provide these types of opportunities. Are we going to start to see now an overcrowding of this space as well as the LLM space, or is just going to be a few key players maybe in what you're doing now, and then all of the people who are engaged in AI now will operate on the LLM level, on the application level, and all that stuff?
Um, well, okay. I'll sort of caveat that this is all a little bit of speculation. Um, what I would say is the sort of data center, training inference business is pretty challenging from a hardware design perspective, right? So if you have a look, so obviously NVIDIA's been doing this for years. AMD has been producing GPUs for years, although they've not been super successful in the accelerated computing space. Intel keeps on trying to get back into the space and has had some challenges, competing in this area too. And then there are, startups, so Grok, GraphCore, Cerebras, us, and a few others. And so, first of all, to build data center class hardware is pretty expensive, and then it's a pretty specialized area of expertise. So, what I see in terms of where so I think that there is some consolidation in the data center side. So with GraphCore, you see that they have struggled recently. I think they it's not totally clear how viable they are moving ahead. Um, in terms of where there's a more of a proliferation of hardware, it's more on the inference side of things. So Esperanto, Tenstorrent, I think was it Brain Chip, or there are a few others in that sort of space where, you know, I, let me kind of oversimplify it, but mostly what these folks are doing is essentially taking RISC-V or ARM and adding some specialized instructions in that to make it work for inference, right? So this is more stuff targeted at the edge, and so I see that requires a lower cost investment, but then there's also lower rewards because the unit cost of that and the economics is certainly much more challenging as well.
Mm. I, I think we were all sort of like on that same page of these because of their high barriers to entry and sort of participation in this space is expensive to say the least, right? So there's only a few people who have the resources and the money to actually do this, but also the expertise. And I know
Yeah,
that there's a few companies out there, and you mentioned a couple of them who are trying to do this. So the companies that already do exist, and it'll be interesting to see exactly where this is going, especially at the turn of this year, where we've started to see significant traction in the generative AI space. So just segueing into that, we've seen a lot happen throughout this past year, much more than we anticipated. And this has obviously been making headlines. We've seen an explosion of development and interest in the AI space. I think previous to this year, AI has always been a thing, and it's been around for decades. But it was sort of like on this a bit of a linear growth, but then now
yeah,
there's this sort of exponential J curve spike that we're seeing with generative AI and so on and so forth. With SambaNova and sort of just with you personally, what is sort of the strategy that you guys are thinking about now? Have you pivoted? Are you still continuing to go down the roadmap that you envision? Or are you adapting to what you see now because it's changing so fast, so quickly? How are you guys making
yeah.
sure that you are on top of what's happening, but then also pave your own path for SambaNova as as this space starts to blow up?
Yeah, so I think there's a lot of different things that have sort of been happening, right? So I think that with ChatGPT when it came out, I think it's almost a year ago now when ChatGPT launched, right? And DALI was available. There were some other things available beforehand, but this is what really sort of captured the imagination. And what I would say is what we saw change for us, right? So we building hardware, we have hardware. Um, I think that prior to that, we saw maybe a larger portion of our business was driven by training, right? So, okay, can we do larger scale training? How can we effectively support training? And then I think, shortly after ChatGPT, there was a different project, I think called Helm out of Stanford, that released a bunch of open models too and qualified them. And it seemed to be clearer that you could, um, you know, take a model, take a publicly available checkpoint and essentially use that as a way to provide capabilities to your customers. And that's even more true with Llama 2, right? So when we launched our most recent chip, we had a demo of it was called the COE, I think. What is it? A Confederation of Experts or something, where essentially we have a herd of llamas that we fit into memory, and they've been specially trained for code generation or on Mandarin or like that. I think we have five or six models that we fitted in memory to provide that. But so the thing that changed for us there was okay, inference is critical. And actually, so let's make sure that we have a look at how we can support that. I mean, I think the fortunate thing for us is, like with hardware development, it always takes some time. So we already had like even though we launched this chip, a month ago, we already had this back. We're in the process of bringing it up, and so it was actually pretty fortunate that we had made this bet, at some time in the past to have this high bandwidth memory on this new generation of chip. That actually meant that it would be very good for inference and also training. And so that happened, well, I mean, we have some smart people at the company that figured that this was a bet worth making. And if you look at where the industry is now, it definitely seems to have proven out by what the market expects.
Hmm. I I mean, it's crazy to see where this potentially is going. And I had a conversation with someone from Hugging Face a couple months ago, and we were talking about the future of where this could potentially go. And what I see right now is sort of a repeat of history, but on the AI level, between sort of analogous to what happened between sort of Microsoft and open source Linux. And
Mhm.
we're starting to see these massive incumbents developing their own proprietary models. But then on the flip side, you have this opposing force of people that are open sourcing their models and building solutions that are freely available to anyone to use. What is your hope for the future? I don't want to put a number of the years, but just in general about where this could potentially go. Is it going to be dominated by closed sourced, or is open source going to be the future here?
Well, I would, from a personal standpoint, I've always preferred open to closed, right? And so I've contributed to open source projects over the years. I even have some code in the Linux kernel from years ago, right? And so I think, you know, the open model of engagement, I mean, model not in AI model, but just the model of engagement and interaction and things, I think has a lot of merits. Obviously, there are concerns around AI and machine learning models and what they can do, and I think using open development methodologies can help allay some of those concerns. Um, you know, I do think it's a little bit of an arms race, right? And so I think what's a little bit difficult in this sort of scenario, say compared to Linux, is in order to be able to train and make your model better, it's pretty expensive, right? You have to have access and ability to use a large number of these accelerators and train, you know, for months potentially to make them effective. But what I see that's quite positive is, in the time since GPT-4 being released and some of these other models too, uh, the open models have been released. They've iterated quickly, and I wouldn't say that they are the same yet. I mean, certainly some of these closed models are very, very effective, but the difference between them is substantially smaller than sort of when they were launched. So I think what I feel will be a little bit interesting is to see where does the innovation come from, right? So at the moment, there's a lot of the closed companies that are leading and the open community that is following. I'd like to see that flip on its head a little bit, but we'll have to see.
Yeah, it probably takes the journey is in and of itself. I would say comparable to what we've seen in the past. There's obviously these big guys that are sort of leading the way, pioneers. There's then the followers, but then the followers take over and then dominate themselves. And we've seen this with things like, obviously Linux, seen this with ARM. So there's definitely a lot of history repeating itself. And as you mentioned, it will certainly be interesting to see. And I, for myself, would love to see the open source community be more actively involved, as they already are in this space, because it is such a fascinating area to be in right now. There's a lot to learn and there's a lot to absorb, and I think people are sort of, scratching their heads to figure out, where this could potentially go, because I don't think anyone knows right now. And it's, as you mentioned much
Yeah.
earlier in the conversation, it's aiming for big, but the question is how big.
Yeah, well, I also think that Again, it feels like history has a habit of repeating itself. So I make an analogy with some of the early dot-com times, right? So I feel that at the moment there's a lot of promise that AI and ML has, but people are talking about the future capabilities as opposed to the capabilities that we have now,
Hmm.
right? So I think, there will be, we are in a bit of a hype cycle, and it'll be interesting to see how things adjust when people are more aware of what's really possible today. And then what happens when the technology catches up with the promise, right? And I feel with, the original .com, it wasn't until sort of Web 2.0 and the smartphone where we really kind of got the promise of what people were talking about in 98, 99, as well. And I feel that there's a lot of things you can do with AI today, but there's a lot of buzz out there that isn't necessarily grounded in the reality of what people can do.
As most things are as well, especially when you
Yeah,
look at the world of venture capital right now and the amount of money going into
yeah,
just anything that moves, anything with the AI tag, gets funded. So I think there's going to be a settling down period sooner or later that's going to figure out who are the people who actually deservedly, receive that capital
yeah.
and see where they go from there. I wanted to maybe do a minor pivot back to
Sure.
sort of your journey with startups, scale ups, and massive growth companies like Dell and VMware. Without going into too much detail in any of those specific companies, I think it would be interesting just to maybe learn a little bit about your general experience working in small companies and big companies and
Yeah,
what you've seen throughout, because there's a lot of nuances that people don't understand about the inner workings of these companies. I'm sure a lot of people here are working for startups. They're
yeah,
probably in startups themselves, but there are a lot of people who are, also trying to sort of understand what's the differences. And especially with you working in technology, working in sort of the mecca of tech right now, what have you seen, and what have you dealt with over the past 20 years, working from the early stage companies all the way to
yeah,
massive, massive, established companies.
yeah. I guess maybe the shorter question is what haven't I seen? But so I think that there are a couple of things I would say here, right? So I think often that there's a perspective for people who only work at small companies that, oh, big companies you're bogged down in process, you can never get anything done, and that, all of that stuff is bad. And, vice versa. Small companies, they're always chaotic. They never really make up their mind. They bounce around between different things. And, the truth is always, somewhere in the middle. What I would say is, um, as you know, I've worked at a lot of places over the years, at various different stages of doing things. And what I think that enables me to have is a set of tools to apply to given situations, right? So, what does that mean? So it means, like, okay, I have a given problem. What is the right thing to try and solve this problem at this given point in time, right? So, when do we introduce a process? When do we want to have more structured testing? When do we want to do some of these things? What, sort of metrics should we be introducing to sort of see that we're getting things done? And you know, I think that that's so um, an effective thing to sort of think through, right? So I wouldn't say that any place that I have worked has it all totally figured out. And um, I worked at a startup, and the founder of that company had previously worked at Cray, and he loved working at Cray, and kind of his goal was to recreate Cray. And I see that sometimes with other people too. And so I wouldn't say that I've ever worked at one company and I've said, okay, this is my template. I'm gonna to do this everywhere I go. It's more okay, given this setup, given these constraints, what are some of the things that we need to do, and how do we need to do this, and when do we need to do this? by, right? Um, an example, right? So it's very easy to say, well, we should have every PR should include new unit tests. Otherwise we should just reject the PR. And I think you have to get to a certain level of maturity before you can start to mandate some of these things. Now, obviously, you dig yourself into a little bit of a hole the longer you wait for some of this stuff, but you need to understand what those trade-offs are. So, I was talking to somebody who used to work for me. He's now working at a different startup, and he was frustrated by you know, some of the trade-offs that we'd made at this particular company, and he felt by going to an earlier stage startup that he could shape things better, right? And I think that it's easy to think of, like you come in and you work at a company, you look at this and you go, oh my God, there's so much technical debt here, it's so hard to get things done. All these people must have been idiots, right? Whereas often what happens, particularly in the startup world, is you have a set of trade-offs that you're trying to make, right? So you're not trying to build the perfect architecture. You're trying to essentially build a thing that gives you a signal that tells you where your market is and that will allow you to drive towards revenue that will get you additional funding, get you, more customers and things like this. And typically you're trying to balance the cost of finding that signal quickly with making sure you don't go insane having to deal with the technical debt that you're creating trying to find that signal. Um, you know, then if you flip it around, so like a VMware or some of these, Sun was a little bit like this too. Um, you have a large number of customers who are using you in the core of their infrastructure, and the cost of making a mistake is high, right? So if you go in and, I think, VMware had like 499 of the Fortune 500 customers, something like that, right? Um, Now, if you cause downtime at JP Morgan because you screwed something up, you know, you're not going to be very popular, right? So the processes that a company like VMware creates is about preventing mistakes and from bad stuff getting out. And so there's still stuff to learn from that, but you need to understand what is the motivation for what you have, and then what are the things that you can take from that to apply it in a situation where those constraints are different, right? So at a startup, you're trying to optimize to get something out quickly to get that signal. And okay, if you have a couple of bugs, you're prepared to live with that because getting that signal is the thing that's critical. Um,
Yeah. I mean, you touched on a bunch of stuff there, and I think the notion of processes can sometimes be a bit intimidating for people coming into sort of large corporations. But I believe, and you already mentioned this, there's always reasons to do it because you don't want to cause outages, you don't want to cause massive problems for some of your biggest clients. And I remember, having friends at Facebook and Google, right, at the early days, right, things is sort of a bit of like the wild, wild west where you can sort of just experiment and do things. But now, you have downtime on Instagram or downtime on WhatsApp, then you're going to get, a mutiny on your hands. So I think
yeah,
there is definitely reasons for doing things. It's not just because you want to make the lives of people harder. I think it's the protection of the reputation of the company, but also the protection of some of its major clients. And I think that was something that I noticed myself working in large corporations, but also going down all the way down to startups and saying, well, I have a lot of freedom here, but this is not going to last forever because you're going to have to establish processes down the road and eventually figure workflows and systems and develop systems in place to sort of streamline things and make things much more capable for your clients as you start to grow and scale and that will helpfully work with sort of like the funding and raising more capital and all those things.
Yeah, well, I think some of this comes down to also understanding who your customer is,
Mm,
right? And that will give you some insight in terms of where do you want to invest.
yeah.
So, like if I were to use say Gmail as an example, so Gmail's a product, and I think most people on the planet use Gmail, and it's very easy when you use Gmail to think that you're the customer, but actually us as users of Gmail, we're not the customer. I mean, from Google's perspective, the customer is the person who's putting that advert in your browser client when you're looking at your email. And so if they're going to optimize for something, they're going to optimize to make sure that they show that advert so they get the revenue from displaying the ad rather than if you click on something and it's a bug and you don't get to see your email or you have to click on it twice. That matters less than if they didn't show the ad because the ad is where they get their money from,
Mm.
right?
Same thing with like
So
YouTube as well. I
yeah,
mean, we've got all of these people submitting videos, which is great to see, but the way that YouTube or Google now make their money is trying to bring people to YouTube to watch as many videos as possible so that
yeah,
the advertisers can get their showtime and get as many eyeballs on that. So the advertisers are effectively paying Google and then pays out the creators and all those people for
yeah.
bringing the audience to YouTube. So there's definitely a incentive, I would say, for Google to optimize their infrastructure for advertisers.
Yeah, well, and even with YouTube as well, like they want to keep you there. So
Hmm.
figuring out how to create that algorithm so the recommended video is something that will make you click on the next thing to stay in YouTube.
Yeah, exactly. With all the stuff that you've been through, we, you have gone through a lot of roles, and you've effectively worked your way up to what is called probably leadership level now. And I'm curious to sort of learn more about that journey, just from being an individual contributor to becoming manager and now becoming, on the leadership team. Was that something that you actively pursued? Was it something that was put forth in front of you where you wanted to sort of just see what it was like? Because I can understand there's a lot of people out there who want to just remain an IC and just want to do
Yep.
the work. But there are others who are a bit more ambitious and they want to lead a team. They want to have direct reports. They want to influence the strategy and the future of the company on that level. What was it like for you to sort of embark on that journey?
Yeah. So I would say, yeah, I am also an ambitious person and I tend to push and right. So, my wife's probably nodding her head in the background if she's listening to this. So, but my journey was a little interesting, right? So I've been an IC kind of since about 1998. I mean, I did do some work when I was doing my honors before I came over here, and I had IC roles all the way up to let's see, just before my son was born. So I became a manager in 2007, right? I guess was it? It was oh yeah, it was President's Day 2007, right? So February sometime. And um, I'd been pushing for more responsibility. I was kind of like a tech lead before that. So, I got up to staff level, staff engineer, senior staff engineer at Sun. I was leading the platform team. So there were a couple of people. I mean, it wasn't anybody reporting to me, but just managing the projects and all of that. And I was keen to get more responsibility, right? And so what happened at Sun was my manager left, right? So he went somewhere else. Actually, he went to a different startup, and so I was keen to get additional responsibility, and I threw my hat in the ring. I think if you'd asked me at the time, if I had a choice between senior IC versus manager, I probably would have chosen senior IC. But this was the thing that was there that sort of came up and that was available. And I thought, I'm gonna go for this. And I had support from the team. I think my skip level was a little uncertain, but she was okay with it and sort of pushed through and did that. And um, I think if you had asked me at the time as well, I probably would have said, "Oh, I'm well and truly ready." I think that, but if I look back now, having those 7 or 8 years of being in IC up to staff level, um, actually was very valuable, to have from management. And so since I sort of switched to manager, I haven't done the pendulum, so I've sort of been in management ever since. So I managed some teams at Sun. Let's see, that was geez, yeah. So I left Sun about 2008, 2009, and then that's when I went to NVIDIA and I was sort of managing the CUDA driver team and created the Tesla software team there. But basically, manager, director. I think I had a stint at senior director. Then I went back into startups. So after Dell, it was yeah. So after Seagate, I think I went back into startups about 2015, and that was when I was here in the city. And so I took on sort of VP of engineering, CTO roles. So VP CTO at Waypoint, VP of engineering at Bitfusion. Then when we were acquired, I sort of back to a director level role at VMware, and then VP over here. But I wouldn't say totally a straight line. I mean, certainly there's some changes in terms of the actual technology, but directionally, sort of going from IC manager, into leadership roles.
What's the one thing that you've learned as a leader, a lesson that you would probably espouse to others as you sort of gone through this journey of becoming through CTO, VP, which are many, obviously all of these are leadership roles, but how do you
Yeah,
see your what's the one lesson that you've learned from all of this?
it's hard to maybe come up with just one. What I would say though is, um, I feel it's super important to remain technical. And that doesn't mean hands-on writing code. I mean, at the moment, I'm not writing code, but I have written code at pretty much every place that I've worked. But understanding what your team is building, having some insight and input into that. But the reason why I think that that's helpful is, um, you know, I think empathy is such a critical thing to have as a leader, right? To understand what your team is doing, what they're building, what their struggles are, and knowing how and when to push them to do the right thing.
Hmm. Yeah, I think the notion of empathy is sometimes underrated, and putting yourself in their shoes. And the good thing is that you have been in their shoes, which is nice, and you're not coming in thinking, occupying this role, not knowing what they've been gone through because you have gone through it yourself, which is always nice. And I think empathy is definitely one of those key traits, and especially from a leadership level, empowering those who are direct reports to be autonomous, to self-manage, to test things and not be afraid to experiment. And I think that's something that, especially in the technology field, is certainly required. Talk to me quickly just about hiring people. I'm sure you've been in a lot of interviews yourself,
Yeah,
on both sides of the table, but
yeah.
as a hiring manager, how do you think about hiring great engineers, great programmers? What do you see? Are you just looking for technical, or are there other things that you need to make sure that they fit?
Yeah, no, that's a good question. So, actually, I've had a question like this before. So, one of the things I look for, so in Ted Lasso, I think he misquotes Walt Whitman, and he says, "Be curious, not judgmental." And so, yes, as an engineer, it's important that people are technically competent and capable. But you want people who are interested in figuring stuff out, right? So why does this work? Why does it not work? What is the real problem? What are we trying to solve? What's the next problem that we might hit once we've solved this thing, right? So people who are prepared to sort of dig in, understand what needs to happen, but also have the ability to take a step back and look at the bigger picture, right? And so I think technical skills are only part of what gets you there. I think it's also important to realize that I sometimes say, engineering is a team sport, right? So, uh, it's not just about proving that you're great or proving that you're right. It's actually working with others and making others better. And sort of related to this, like part of the reason why I moved into management and leadership wasn't because I love dealing with people, but because I had a realization a long time ago that if I want to build something that is bigger and better than what I can build myself, I need to work with others, right? And so I try to look for people who have a recognition that part of their job is to work with others and make them better too.
I definitely align with that. And you can't operate in a vacuum. You can't operate siloed. And as many people will like to think engineers just work off in their own cubicle or in their own bedroom by themselves. I mean, it's an outlier. You definitely need to have a group of people, a community around you. And this is just, again, history repeating itself with the open source community. You know, the way you build great things
Yeah,
is to get people on board and inspired by the mission. And I think being someone who's able to bring people like that together is a real quality and trait in and of itself. And I think, hiring people like that is definitely something that is obviously very key, but helps sort of you grow and as a leader, but also gives you sort of like the lessons that you need to learn about how to manage a team, how to sort of work with those types of personal people management, as well as
yeah.
technical as well.
Well, so I think, to your earlier question as well too, right? So part of what you want to try and do is unlock the capability that your team has. And if all you're doing is telling them what to do, you're not going to do that. So you want to have great people around you who will think of things that you don't think of and make things better without necessarily you having to think of how to make it better yourself.
Yeah. I want to maybe just sort of tail off with some questions I usually ask at the end of every conversation, and this could be something that you do on a daily basis, or but also just giving people more insight into your personal interests as well. The first question is really about are there any recommended podcast or books or pieces of or blogs that you like that you are an active reader of or a listener to that could hopefully help other people as well.
Yeah, so I had a couple of thoughts on this one. So I'm not an active podcast listener. I tend to read more than I listen. And so also with my day being so totally chopped up, blogs and things like that tend to be the best thing that I find for my own uh, education and things too. And so there are certainly a couple that I look at regularly, but it's funny. So I do a lot of mentoring. So one of the things I actually typically ask people is a variation of this question, which is how do you how do you learn? How do you like to take information in? And so, like for me, I actually feed in a whole lot of RSS feeds and things like that into a reader that I have on my phone or on my desktop that I can look at. And so I look at things like, so First Round has a lot of great content, although the articles are a little bit long, so sometimes you have to be a bit patient to kind of get through it. From a management and leadership perspective, Lighthouse has some great information. Rand, so like Rand's in Repose, so there's a Slack community that Rand's has that you know runs the gamut. So they have some good staff plus engineer forums within that, but just a whole set of different things there as well. Um, then there's probably a few things I'm spacing on. Books, there are a few books that I think are great. I regularly recommend The Hard Things About Hard Things by Ben Horowitz. I just find that's kind of it's a really good sort of perspective, and also I think timely, with this sort of wartime, peacetime CEO stuff that he has in there right now, because yeah, it kind of feels we're a little bit more in the wartime economy just now than the peacetime economy. Um, then let's see. There's a couple of others, obviously Andy Grove's books, high output management is great, but there are a few things like that. But what I'd sort of recommend is sort of read widely. So one of the things I've gone into a couple of different disciplines over the years, and what I typically do is I try to source good areas for information on these things, right? So there was some stuff I was doing in e-commerce, and I got a whole bunch of e-commerce blogs and things like that that I was reading. When it came to doing full stack web development, pulled in a whole bunch of things with respect to that. So, and what I find with having a decent reader, it allows you to either skip through these things quickly, but then also find the really excellent nuggets of great information.
Yeah, that's great. And I'm sort of the same thing. I do listen to podcasts myself, but if I don't have the time or whatever, I think reading is such a sort of a nice way to absorb information, and whether it be blogs or through books or whatever, I think that's a great way to um, sort of maintain your breadth of knowledge, but also have that depth of knowledge as well. So I feel like there's definitely a lot of opportunity there. Next one is mental models. I think I asked this one because I'm always interested on how people make decisions. I think everyone is faced with decisions every day. We go through thousands and thousands of
Yeah.
decisions, but more succinctly, we go through a lot of hard decisions in our life, in our professional life as well. You've got to make this decision. You've got to hire this person. Are there any ways that how do you think about making decisions that are tough?
Yeah, so I try to take a step back and be objective, but I think there are some frameworks that are good. So actually, I'm sort of surprised how well it's not super well known about RACI or DACI. I don't know if you're familiar with. So RACI is responsible, accountable, consulted, informed, and I think Atlassian has a version of that. Driver, accountable, consulted, informed, right? So what is useful about this framework is yeah, really getting down to roles and responsibilities. And so where I found this to sort of be helpful is particularly at early stage startups. Um, you think that everybody has to be involved in everything, right? And actually, that's kind of a bit of a recipe for disaster. Not in the sense that you're just going to suck everybody's time, and as you grow, it's going to make it really hard for you to make decisions quickly and move quickly. So figuring out who has to do what, and then who needs to be in what meeting, who doesn't need to be in what meeting, how do you communicate? So I found that RACI is kind of a good way to have a look at decision making and project planning and things like this in a way that allows you to sort of tease apart the hey, we need to have everybody in a room and get consensus to do a thing.
Got it.
Um, yeah,
And then finally, last one is, you're obviously super busy, but it'll be interesting to learn more about your daily routine and sort of just a general overview of what that looks like, and how do you manage your time. You're obviously topped up with a lot of meetings, a lot of interactions with people at work, especially on that
yeah,
leadership role. But obviously you have a family, and how do you
yeah,
balance all of that?
yeah. It's a good question. I think trying to make sure you're present when you do things. So like my morning, so I typically get up at about 6:30, 6:45. I'm responsible for making the kids lunch, getting them out of bed, getting them ready for school, and then if I'm going south to Palo Alto, I'll drop them at school before I hit the road to go to work. I mean, pretty much, like depending on how early I start, I might take a call from the car, but mostly from about 8:30 to at least 5 is pretty much slammed, right? It's like I have something every hour, every half hour of the day. Typically, actually got me on a good day today. Today is one of my better days. Um, and so, go around, a bunch of it is one-on-ones, but there's also, like we have to have meetings to make sure, the work gets done, what's critical, what's important, how do we push for those things. And then, like, uh, come home. Certainly lately it's not been so good. I mean, during the pandemic, I was a little bit better at being home and cooking dinner. I think I still cook dinner a couple of days a week, but not. I don't know that I'm doing my 50-50. I think my wife is taking a little bit more of that just now. But I try to sort of be present, sort of at that sort of dinner time. After time with the kids, watch some TV. I'll sort of respond to things on Slack, but try to only sort of pull out the laptop in the evening for critical things. I mean, I will try to fit in exercise, on different days. I'll go out for a run or I play field hockey. I do think just having some of that is important, but I've coached my kids' sports teams and things, but yeah, it ends up being that um, there's very little downtime at all, whether it be the weekends or whatever, until it's time to go to bed.
Uh, that's definitely not uncommon, and I definitely applaud everything that you're doing because it is always a balance, but it's manageable as well. The last thing you want is burnout. So it seems like you've got a nice routine going on there. What's the best way for people to connect with you?
So probably the best thing. So LinkedIn, I'm
Yeah.
on there. I mean, typically, if I am pretty good. If people reach out to me and are interested in just having a chat about something, I'll respond. I get a lot of pings for people who want me to spend money with them. If it looks like you're asking me to spend money, then I will mostly probably ignore you. I mean, I am on Twitter and things, but I think LinkedIn and or email is probably the most reliable way.
I think, yeah, everything that sounds great. Thank you so much. I will definitely put all the show notes, whether it be the recommendations on books and podcasts, but also all the mentions that you've made in the show notes. And it was great to have you on, Peter, and hopefully look forward to reconnecting again.
Okay, great. Okay, thanks, Barry.